Assalamualaikum and good day. Welcome to our session of online learning. Now this is chapter 4, structural design of flexible pavement. We have covered in chapter 1 the material, chapter 2 the hot mix asphalt design, chapter 3 the road construction, and now this is the design of the pavement itself. How to determine the thickness of every layer. This is just the standard design procedure. Later in my next video, we're going to see on how to construct using one standard design procedure. Okay, the structural design of flexible pavement, as you can see, that's the picture of the pavement that has been cut. Okay, we're going to look at the element of flexible pavement structure, factors to be considered in the design, method of design for new pavement, and the last one is Malaysian design method. Okay, the aim of the design is to design a structure that will ensure that the transmitted stress are sufficiently reduced and do not exceed the capacity of the underlying subgrade. The two stress and strain that are important is the horizontal tensile strain at the bottom of the bound layer and the vertical compressive strain on our subgrade. Those two values should not be exceeded. Okay, these are the elements of a flexible pavement. We have down there subgrade. Okay, it is the uppermost layer of natural soil or backfill which will support the load transmitted from the top layer. Second, subbase. Subbase is a secondary load spreading layer which will prevent the infiltration of the subgrade to the road base. It will act as a construction platform, and if there is no drainage layer, it will also act as a drainage layer. The most important, road base. Road base should be used specific material. It is the main load spreading layer. It will provide pavement with added stiffness and resistance to fatigue. And then, on top of it, we have surfacing consists of binder cost and wearing cost. These two causes, surfacing is the uppermost layer, will provide safe and comfortable riding surface. Remember, this surface interact with the road users. It will withstand all the traffic stresses, protect the lower layer, should be impermeable, meaning that the water should not penetrate this layer. Should be flexible, of course, because this is a flexible pavement, and it may consist of binder cost and wearing cost, or it may just have wearing cost, or it may have three layers. All of it constructed from hot mix asphalt. Next factor to be considered in the design. First, the failure mechanism. When did we say our pavement fail? There are two of concern, which are permanent deformation and cracking. What is permanent deformation? Simply rut. What is rut? It is accumulation of permanent strain, and if it's rut, the water will start to pond on the surface and it will endanger the road user. Second, crack. What is crack? That is a fracture failure under repeated stress, and it may also come from fatigue failure of the bituminous layer. That's the first one. Second one is traffic loading. Of course, we design the pavement to cater for traffic. Then it must account for all these load, which are tire load and pressure, because this will have contact on our pavement. So the pressure is, what pressure is? Force divided by area. The more the contact area, the less the force and the less the pressure. Axle and wheel configuration. That is why most heavy vehicles have more wheels, more axles, compared to our normal passenger car, which have two axles. Okay. Load repetition. How many times those heavy vehicles pass on our road? Traffic distribution. Normally, the slow lane consists of more heavy vehicle compared to the fast lane. And direction. Maybe the northbound carrying more load compared to the southbound. So the northbound will last less shorter time compared to the southbound. Speed, of course, we can see if the road is climbing with a positive gradient, okay, the speed of vehicle is slow. When the speed of vehicle is slow, then the contact time going to be longer, the loading period longer, then the road is exposed to more load compared to the high speed lane. And then another thing is equivalent single axle load. All the load on the pavement need to be converted to equivalent single axle load. What is a standard axle? Standard axle is a load an axle with 80 kilogram or 8160 kilogram or 80 kilonewton or 18 kips. How to convert it? We convert it using equivalent factor. Load of our axle divided by standard load 80 kilonewton to the power of n. Okay, and we only consider commercial vehicle. Okay, commercial vehicle is a vehicle with unladen weight of more than 1.5 ton for arahan teknik jalan and 3 ton for road note 31. The third factor, environmental, of course, temperature, because asphalt is very temperature susceptible, and moisture. Moisture for the safety of the road users and for the safety of our pavement. Okay, when I talk about commercial vehicle, these are the classification of commercial vehicle according to Arahan Teknik Jalan 585 2013. Okay, we have cars and taxi, we have small lorries and van, we have large lorries, we have articulated lorries, we have buses, and we have motorcycles, 2, 4, 6 classes, and it goes with C, CV. CV stands for commercial vehicle, C for cars, and MC for motorcycle. And on the last column, we have load equivalent factor, which is L divided by LS to the power of 4, as mentioned before. If there is no classification, we just assume the load equivalent factor as 3.7. Okay, let's look at this vehicle. Cars and taxis with the load equivalent factor of 0. Those are cars and taxis. Small lorry and van. That's small lorry. And that's commercial van with the equivalent factor of 0.1. Large lorry, 2 to 4 axle. CV2 with equivalent factor of 4. That's one of it. That's another sample of it. Okay. And then we have articulated lorries, 3 or more axles. CV3, 4.4. One of it. And another sample of it. Buses, of course. Is a 2 axle or 3 axles. Okay. Equivalent factor of 1.8. And last one, motorcycles. Okay. Those are the 6 categories of vehicle. Okay, now let's look at the method of design for new pavement. What is the objective of our pavement design? The objective is to determine the number, the material to be used, and the thickness of each layer, so that it will be able to sustain all the anticipated traffic loading. Remember, number, the material composition, and the thickness. That is our objective. There are 3 methods. Okay, the old method, rule of thumb methods. Okay, the precedent. What's it? Standard thickness for particular road classification. R5, this is the thickness. R4, this is the thickness. That's the old method. Second, empirical. Now they use the soil classification, soil strength test, added with experience, experiment, or both to design the thickness. And the last one is theoretical or semi-theoretical, which called mechanistic, and use a lot of computer programming, the try and error using the material properties and so on, mathematical model to get the thickness of each layer. This is the general design process. Okay, doesn't matter which method you're going to design your pavement, but it has to go through this design process. First, select the design life of the pavement. How many years? 10 years? 20 years? And then second, assess the annual traffic growth rate. What's the growth rate of your traffic? 4%? 5%? Assess the number of commercial vehicles, because as I said, only commercial vehicle is counted or taken into consideration in design the pavement thickness. Okay, and then assess for, let's say, your design life 10 years, how many cumulative traffic loading? What's the value of traffic loading for that design life? Check your subgrade. As we learned in chapter 1, the CBR value. Okay. What is the CBR value of your subgrade? The higher the CBR value, the stronger your subgrade is. And then select the material to be used in each layer. Remember to use local material. Okay, try to use as much as you can of the local material. And then calculate the thickness. And of course, we as engineer, we love to look at just the sketch. Sketch the structural pavement. Wearing cost 50 mm, binder cost 100 mm, and so.